Two and a Half Admins, episode 109. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. IEEE published an interesting article recently on their Spectrum publication. The math proves it. Network congestion is inevitable. And sometimes solving traffic problems can just make things worse.
You know, we see the same thing, like their analogy here about real highways. Sometimes if you put too many traffic lights too close together, it actually makes it worse. And a lot of times, everything you do to try to control things have unintended consequences and just make things different. That's why there are so many congestion control algorithms for TCP/IP. For a long time, we mostly used the default one called New Reno. The original one was Reno, and then they added an improvement to it called New Reno. But those ones were mostly loss-based. So their basic concept was, if we're sending too fast for the network, the packets are going to get dropped because the tiny CPUs in the network devices won't be able to handle it. And so anytime there's a drop packet, we assume it's because we're overloading the network, so we need to slow down. But then if you have a connection over, say, Wi-Fi, where packet drops happen because other noise in the air or whatever, suddenly that missed packet isn't necessarily a symptom of congestion. And we got, this concept of buffer bloat, where suddenly it was the devices are less likely to drop traffic when they're busy and actually to buffer some of it and try to squeeze it out again, because unlike when everything was based on wires, we don't get the same speed all the time. Their environmental conditions affect wireless and satellite and so on a lot. And so then we started looking at things like, if we see a spike in latency, maybe that's caused by the congestion, and all these different ways of trying to detect the congestion so that we know when to slow down and not overdrive the network. But part of that also assumes that everybody on the network is trying not to ruin the network. Whereas if you're just a little greedy, maybe you can get more out of the network than other people and cause them to wait in the queue while you get to barge forward. And then we started to see different algorithms. Like there's one called RAC that Netflix uses because their use case is kind of weird. All of these original congestion control algorithms assumed you wanted to send data to the other end as fast as you could, right? That the common case was, say, downloading a website or a file from a website where you're going to communicate with the other side and try to send it as fast as the two sides could cooperatively send it. But when you're streaming video, oftentimes what you're doing is getting a couple of minutes of video, and then the connection goes idle for a little while you watch that bit of video. And then once we're getting near kind of the end of that chunk of video, we download another one, possibly from another server. But when you kept that connection open, all that time when you weren't sending a lot of data was messing with the algorithm as far as knowing how much bandwidth was left. And so then when you suddenly started sending a big chunk again, it would not be as fast as it could have been, and it was getting all weird. And the congestion control algorithms were not designed to handle this kind of sawtooth pattern of send a bunch of data, then wait, send a bunch of data, then wait. And so they had to come up with yet another different one. And now we have all these different ones, and they kind of depends on the use case, which one will be the best. And then the fact that each side gets to pick their own means that it gets very complicated, and that, most of these are just based on a relatively simplistic guess of what does this input signal mean? When a packet gets lost, does that mean that a packet just got lost somewhere? Or does it mean that we're driving this connection to almost as fast as it can go? Or is that what a jump in latency means? Or is that just the fact that I'm on my phone and I just roamed from one tower to another and there was a spike of latency there, or I went through a tunnel or something that just caused this burst of latency or packet loss or both? That doesn't necessarily mean that the performance of the network once it comes back is any different than it was before. But the algorithm assumes, a lot of these algorithms were based on the idea of these are fixed computers at military bases that are just trying to send information to each other the same way they do every day, and not that we're going to be moving around and all have changing conditions.
They also frequently are quite naive. Alan touched on this when he mentioned the L word in his own rant, latency. A lot of the problem is that many of these algorithms were tuned very specifically for the highest throughput possible. They want to produce big numbers on a speed test. Well, you can produce great big numbers on a speed test and still have an absolutely crappy internet experience because the way to get that big number turned out to be, this is where that whole buffer bloat work comes in from. You have this enormous buffer that you stuff full of as many packets as you can, and you get them across the network as you can get them across the network. And the buffer is supposed to smooth everything out so that you get the highest continuous throughput possible. And if what you want is the highest continuous throughput, that might be great. Unfortunately, a lot of the time what you want is lower latency. And the difference is latency means you want something to react as quickly as possible after you give it an input. You want it to do the thing that you wanted it to do immediately, rather than it taking a while as it chews through all this crap in its buffer before it ever gets to sending your request. So the same congestion control algorithm that works great for one person with one workload may not work that well for another person with a different workload. There is no one algorithm to rule them all, and congestion is absolutely going to be inevitable when you start getting beyond, not only are we just talking about, well, let's try not to lose a packet, but let's try to have a good internet experience out of this, because one person's good internet experience is going to be another one's mediocre one at best, and vice versa.
Right. And when some of these algorithms were designed, the devices didn't buffer like that because they didn't have memory to store the data temporarily. The connection was 3 megabits, 128K buffer on that would be a huge fraction of the capacity. That's like a third of a second worth of data. And the amounts that everything is scaled up where these devices can buffer so much data, it's like the amount of buffer you can get across this whole connection is more RAM than was at any one machine when these algorithms were invented. And they didn't account for that. And they thought, if you ever try to go too fast, we're just going to throw things on the floor and make you send them again. Not that we're going to buffer them to give you a slightly better experience. And they probably also just never assumed that we were doing live face-to-face video calls where we want to hear what the person said within 100 milliseconds of when they said it, not just eventually. Or that we're still using TCP for it, but sometimes we actually don't care. Like if you get behind, we're just going to throw it away and get caught back up.
Again, I think it's worth pointing out that, how it's marketed and how people, end user type people, not just us snooty admin types, actually test it and decide what's good or what's not. And when you don't have a lot of knowledge of the problem space, you can frequently test in very problematic ways that lead you to choose poor solutions. And the enormous buffers didn't appear out of nowhere. They appeared because it became a relatively inexpensive way to ensure that the throughput number would be the highest you could get off of an internet speed test. And when you get Joe and Bubba six-pack together, and they each have a different model of modem, and one of them's like, well, we have the same internet connection, but I got 130 megabits and you only get 124 megabits. Well, Joe and Bubba are usually going to decide that the 130 megabit was better. A lot of the time, it may obviously be that things aren't quite as laggy in the house with the slightly slower internet connection, but they may never actually make that connection. Because you don't have that technical background in thinking about things that way, where you've got multiple metrics and they can conflict, and prioritizing one metric may push another desirable metric down, then you're not necessarily going to notice that correlation. You're just going to be mad because, well, the internet sucks today. And you're not going to think to connect it to anything like that because why would you?
Yeah. And as the article goes on to say, people have come up with hundreds of these congestion control algorithms over the last 40 years, and there's still no clear winner. This one's better in that situation. This one's better in this other situation. That one falls down when you try to, make a connection to the moon and so on. But all of them have this other problem of they don't manage to achieve the fairness they aim to have. Part of the idea of congestion control is that if there's a bunch of people sharing this connection, we want to make sure that one of them isn't getting shafted and getting almost no internet while somebody else is getting lots. We're trying to make it fair by having all of them react when they get the signal about a lack of bandwidth, which is usually, before was always packet loss or increased latency. But we also have now this concept of explicit congestion notification, where devices upstream could actually send a message back saying, hey, you're sending more than the network can handle. I'm explicitly telling you, slow down, not a vague signal of dropping a packet that could mean something else. This is saying, hey, explicitly, you need to slow down. But not much hardware supports that yet. And it still relies on the other side taking that signal and actually doing something about it, and not just being like, yeah, but I want all the internet, so I'm going to just keep going anyway and screw the little guy that actually, gets the message and slows down his connection. But one interesting thing is the way a lot of this research is done. So FreeBSD was one of the first operating systems to offer pluggable congestion control, where you could load all these new congestion control algorithms as modules and switch which one you were using on the fly and see how that worked. That was great for a while, but now we actually have selectable both the congestion control and the entire TCP/IP stack on a per socket basis. So you can actually configure your system so Nginx that's dealing with file downloads can use a certain congestion control algorithm to optimize throughput, but you can have the video calling app use a different congestion control that's trying to optimize that stream for the lowest possible latency. Although in the end, you still end up with, you're going over the same pipe. And if the bulk throughput one is not cooperating at all, it's not going to help you so much. But being able to say, for my control connection for that SSH, I want to go with, it doesn't have to be fast, but it has to be reliable. If maybe I'm coming over a crappy link because this machine is in a plant or, up a TV tower or whatever, I want to go for the one that's most reliable. And I don't care if it's very fast because it's just my command connection. Whereas if I want to do video calling, I want low latency, or if I want high throughput or whatever, the ability to select those for individual applications gets to be pretty interesting.
Okay, this episode is sponsored by Tailscale. Go to tailscale.com. Tailscale is a VPN service that makes the devices and applications you own accessible anywhere in the world, securely and effortlessly. It enables encrypted point-to-point connections using WireGuard, which means only devices on your private network can communicate with each other. Unlike traditional VPNs, which tunnel all network traffic through a central gateway server, Tailscale creates a peer-to-peer mesh network. It handles complex network configuration on your behalf, so you don't have to. Network connections between devices pierce through firewalls and routers as if they weren't there, so there's no need to manually configure port forwarding. Tailscale is available for Linux, Mac, Windows, Raspberry Pi and ARM, Android, iOS, Synology, and for devices that don't allow additional software to be installed, such as printers and other embedded devices, where you can set up a subnet router to act as a gateway, relaying traffic from your Tailscale network onto your physical subnet. So go to tailscale.com and try it for free on up to 20 devices. That's tailscale.com. Let's do some feedback then. M says, listening to a recent episode, in response to a query about DNS, Alan mentioned that he wasn't worried about privacy, and I wanted to explore that if possible. It struck me as odd, as a not insignificant portion of non-Windows and Mac users have privacy concerns which contribute to their non-Windows use. Is it purely on the professional and enterprise side of things, or do you feel any different in the private and personal side of your tech journey? Or do you believe it's already a lost cause, or simply don't care at all? Same questions for Jim if he feels the same or any different. And finally, if you do have any privacy concerns, are there any tools or practices you would recommend in a sysadmin setting? I'm aware that people can sometimes conflate or confuse privacy with security. I have zero doubts in any of your abilities to secure your digital lives. This is purely about privacy. I'm also aware that some members of the privacy community can be judgmental to the point of toxicity. This is also not what this is. I'm only interested in your views, not out to condemn.
The short version for me is there's not anything I'm really worried about for privacy that you can get out of my DNS requests. It's just such a limited set of information. Like, you know that I go to reddit.com. You don't know about, whatever weird subs that I'm going to, because that's below the DNS level. If there are entire sites that you would rather nobody know that you go to, then it does become important. That's just not really the case for me. I mean, I think the closest thing to a dodgy domain I could potentially be embarrassed about is, something like Pornhub or whatever. But if you want to know if I look at porn, just ask me. Yeah, I do. All right. Privacy concern over. I think the biggest issue, frankly, realistically, is going to come for gay and trans folks who are closeted about it. I could definitely see it being a big privacy issue if you're a closeted gay person and somebody knows that you're going to, gay interest focused websites. Like, that could be a problem. It's just not a problem I personally have.
Yeah, or reproductive health stuff, potentially.
Yeah, and I think to Jim's point, it's just DNS is not high on my list of things I'm worried about, because even if my DNS was encrypted or gone off somewhere where they couldn't see it, if they're monitoring my connection, unless I'm VPNing as well, they're going to see me make the connection to the website after the DNS, whether I did the DNS or not in the end. So yeah, it's just that DNS doesn't have enough information that it's so far down the list of things I'm worried about that I don't matter. And I also, partly is that my internet traffic isn't that interesting. I'm not saying that other people shouldn't be worried about their DNS exposing things. And like Jim was saying some examples there, or activists or just dissidents in certain countries where that kind of thing is not allowed, it can cause all kinds of havoc. So I'm not saying that nobody should be worried about their DNS, just that I'm not worried about mine, mostly because there are bigger things I can worry about that will be more impactful.
Yeah, that's the big thing is even if you're worried about your DNS, it should not be even close to the top of your list of concerns. If you're concerned about people finding out what you're into and what you're doing, you should be a lot more worried about the web giants who are embedding, JavaScript trackers in pages and fingerprinting your browser and figuring out where all the way down to the individual page you're actually going. You could look at my DNS and say, hey, that guy looks at Pornhub, but you're not going to know what I'm looking at there. On the other hand, if you're an Amazon or whoever, maybe you do, because maybe you've got web trackers in there that have not been sufficiently scraped. Now, in my personal case, probably not, because I'm using privacy extensions in my browsers that look for and strip out those things. But that's by far the bigger concern, because those web bugs, they have the potential to know exactly what you're doing, whereas DNS is just the barest hint of it.
Are you telling me that bugs might reveal the fact that I'm searching for Taylor Swift fan sites?
We all know you're searching for Taylor Swift fan sites, Joe.
Damn it.
And as far as the non-Windows part, my journey to Unix was mostly I wanted to run an IRC server. And so it really had nothing to do about privacy.
Yeah, and you're sitting here talking to us on a Windows box right now.
Yeah.
I wanted to be able to serve content to the entire internet was the start of my journey. And ftp.cd-rom.com was managing that out of, bitty little beige boxes running FreeBSD, and was the most, at the time, highly trafficked site on the internet, managing it on a few beige boxes. So I was like, obviously, this is what I need to do. And although FreeBSD isn't my number one OS of choice anymore, I'm more a Linux head these days. That's still kind of what it comes down to. There's just so much capability that I can't get out of a Windows box or a Mac that I get out of Linux or BSD machines, that's what drives my choice.
Yeah. I came to using it as a desktop at the end of using it as a server for a decade first, which I know for a lot of people, the journey's the other way around. You start using it as a desktop for privacy reasons or just to avoid the Windows license or whatever the reason might be. And then you maybe get sucked into using it as a server. But for me, the journey was very much the other way around.
Yeah, it was the same way for me too. I was FreeBSD in the server room and Windows the desktop, and I just shelled into my servers for quite a long time. That didn't begin to change until Ubuntu Feisty Fawn, which I think was 2007. And I was like, okay, hey, here is a Linux that is fully, completely usable, and I can switch to this and not hate myself. I had flirted with FreeBSD on the desktop and various other Linux distros on the desktop before that, and come to the conclusion these all suck rocks, and Windows is a much better desktop than any of this stuff. But beginning with Feisty Fawn, that stopped being the case, and I just ditched Windows like a bad habit.
Okay, Clifford said, I wanted to chime in quickly on the recent episode where the issue came up of whether Linux would be patched for 32-bit x86 processors. I felt the need to offer some insights as to why some are panicking. I can't speak for all, but there is a sizable cottage industry that exists mainly to take old hardware and repurpose it. This is nothing new. The kicker, however, is that there are many small IT consulting and MSP shops out there who have deployed various networking solutions that are built from repurposed end-of-life commercial devices. I have first-hand knowledge of a consulting company in the upper Midwest that for at least 5 years bought pallets of old decommissioned checkpoint firewall devices that had 32-bit x86 CPUs in them. They'd put some Linux firewall distribution on them and install them on-prem with a client. This one shop easily had 1,000 or more network boxes out there at accounting firms, police departments, schools, medical clinics, etc. I don't know how much repurposing end-of-life devices played into their pricing for services, but I'm sure they'd have a fit if they need to replace them. I'm not saying it's right, I'm just saying it is.
Yeah, but at the same time, if you're the maintainer of a kernel and you're looking at it, it's like, well, they've not really mass market produced new 32-bit x86 hardware for more than 10 years. Do I really want to spend all this time applying the Spectre Meltdown type mitigations and whatever the future ones are going to be to 32-bit and guaranteeing that I'm going to do that. And that's why FreeBSD's policy now is that 32-bit x86 is tier 2. We will do it if it's easy, but if it's hard, somebody's going to have to pay for it because nobody's going to do this for free for fun.
I'd just like to point out that what this company has actually done is, they bought thousands of abandoned devices on pallets that used a deprecated platform architecture and slapped somebody else's distribution on them to do the thing. It's bottom dollar dumpster diving, and there's only so much warranty you get out of that. You can't just get infinite support for free on things that who's paying for it? I'm losing my words here. This makes me so upset. It's just, it's so entitled. You should have to support all this crap that I got out of dumpsters for free forever. There is no end, period. I'm not the bad guy here.
Yeah, I base my whole business on selling unsupported stuff and whining when people won't support it.
Yeah, so ultimately, there's nothing wrong with that business model necessarily, but part of that business model is being aware of, has this platform architecture been deprecated, which 32-bit x86 has been deprecated for quite some time now. And, understanding that okay, well, is it still technically supported? All right, well, maybe there's still a business model here for taking it and selling it for a low enough cost that either you can afford to replace it if you need to, or you can make your customers aware that look, you're getting a very inexpensive solution here, and we don't know when the last of the support is going to drop off here, and there will be a hardware upgrade necessary at some point. This doesn't change for somebody selling old busted crap that they bought off of a pallet any more than it did for the people that are building quote unquote new solutions out there. Things change. Technical debt accrues. You have to be aware of the technical debt in your particular stack. You have to own it. You have to manage it. There's no getting around that. I'm sorry.
Yeah. In this case, this company doesn't have to replace all that hardware. They just have to pay someone to patch 32-bit x86 on Linux for them, if that's what they got to do. But it does really seem like their business model was selling technical debt to other people.
Hey! Thank you, Alan. That was the concise soundbite I was reaching for and failing to grasp in my outrage. Yep. Repackaging and selling onward technical debt. That is exactly the model.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support, offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. And check out their managed MySQL, Postgres, and MongoDB databases that allow you to quickly deploy a new database and defer management tasks like configuration, managing high availability, disaster recovery, backups, and data replication. Simple and fast to deploy with secure access, their flexible plans include daily backups. So go to linode.com/25A, create a free account, and you get $100 in credit and support the show. That's linode.com/25A. Let's do some free consulting then, but first just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to learn more about that, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Okay, Donald says, I'm looking to fit 3 TP-Link ceiling-mounted wireless access points. From the reviews I've read, it looks like they each come with a PoE injector. I know the tidiest and best way to set them up is with a PoE switch, but I have a non-PoE switch in my drawer which would do the job. I also have a bunch of Ethernet cables. My question is there a reason, beyond avoiding a mess of cables, why I can't just use the 3 PoE injectors with my existing switch?
At that scale, no, there's no reason why you shouldn't do that. One of the less obvious things that I would like to point out, because I've seen a lot of people not quite realize this, the injector does not have to be in the same room as the access point. You can plug the injector in where the switch is in your network closet or wherever you hide away the bits and bobs that, not all the normal mortals see. And the power will travel over the long Ethernet cable all the way to the access point just fine. You do not have to have an injector plugged into an outlet like directly underneath the access point with like a wire come out of the wall into the injector and from the injector to the AP. Nah, just out of the switch in the closet into the injector, and then the line that goes all the way from the closet to the AP, that one carries both power and data. Now, if you're at a larger scale, I would say don't do this for a few reasons. Probably the biggest one just being that you will consume a little bit more power running multiple injectors than you would with just a single PoE switch. But at this scale, where we're just talking about 3 access points, it's really not a big deal. If you're just not feeling it, you don't want to go out and buy a relatively cheap 8-port PoE switch, then don't. Use the injectors. It'll be fine.
Yeah, it comes with the injectors for a reason, because most people are going to have some small number of switch ports on their router or whatever their internet comes in on, and it's probably not PoE, and they can use a couple of injectors to get 2 or 3 of these. Like Jim said, unless you're getting to a bigger scale where putting it all in one chassis and doing the AC to DC conversion once is going to be better for efficiency, like for a 3, it's not going to make a big difference.
I'll be real with you. I got 6 access points in my house, and when I bought my switches, I didn't yet care about PoE. So I got a house full of non-PoE switches and 6 access points, and yeah, I got 6 injectors plugged in my network closet.
Right.
But yeah, the entire promise of PoE is not having to have the power in the same place as the AP. And it's amazing, like Jim was pointing out, the number of people that don't realize that and are like trying to put the AP where it's going to be able to get power. It's like the whole point of PoE is being able to put it where it makes the most sense for signal reasons and put the power wherever it happens to fit in your infrastructure.
Yeah, in your basement with all the network gear and just a big mess of cables that are not managed in any way.
I don't know if I've ever shown a picture of my laundry room in the last couple of years, but yeah, it's just a punch down block, a switch, and like a bunch of dangly bits, and it's ugly and everything, but it just comes out as Ethernet jacks all over the house.
Laundry room. Son, I am disappointed. Why is it always the cleaning supplies that go with the network stuff?
Basically, it's the one room in the basement that doesn't have a ceiling, so it's where it was easy to route all the cables to. It's also where the electrical panel was, so it's all the stuff is just there.
I hijacked a coat closet for mine.
In the house I lived in before, it was in the hall closet, yeah. With a computer, which got that closet nice and warm.
One thing that's worth mentioning here, though, is that the cost of electricity keeps going up. So how much difference are we talking about here? I mean, if on the scale of 3, it's probably not that much, but like over a few years, isn't that going to add up potentially to quite a lot?
Over a few years, it might add up to $10.
Right.
Yeah, you're talking like single-digit watts here, basically.
Yeah. And to be clear, I said over a few years, it might add up to $10. It's not going to hit $10 in 1 year.
So it doesn't make economic sense to splash out on that PoE switch then?
No, it really doesn't. Probably the bigger potential difference, and this is going to depend on climate, you're definitely generating more heat with 3 injectors than you are with a single PoE switch and a single power supply. In my climate, in South Carolina, the United States, every additional bit of extra heat that's going to the house is a little bit extra on the cooling bill, and that's going to make more of a difference than the actual direct power wastage itself does. But again, at this scale, it doesn't add up to enough to really worry about. I do know there are a lot of folks out there who just kind of on a philosophical basis get real concerned about it. And they're like, I don't want to burn 1 extra watt above and beyond what I don't have to. If that's an ideological thing and it just makes you feel better, then yeah, go ahead and worry about it. But if it's a practical thing, you're just like, I don't want to waste energy that I don't have to. There are absolutely more wasteful things in your house for you to tackle than worrying about this.
Yeah, that was my first thought when Joe brought up, is the cost of power going to be enough? It's like, if you have 1 incandescent bulb left in your house, it's wasting a lot more power than all these PoE injectors put together.
Yeah, and if you're thinking on a more global scale, the energy required to make that PoE switch is going to be quite a lot. And reusing an existing switch and not just throwing that away and making that e-waste is surely better.
Well, unless more and more people buying PoE switches convinces the industry to make that become more of a normal and supply PoE and a lot more switches and stop making an injector that tremendous numbers of people are just going to immediately e-waste when they buy their APs because they're not using the injectors, they're using a PoE switch. So there's arguments either way on that one, honestly.
I kind of feel like why don't we see more routers, or especially the combo modem routers, having PoE? Like most of them have Wi-Fi built in, but having one Wi-Fi access point in your house that's usually has its location determined by where the service penetration in your house is. It's like you're definitely going to want more than that. And why don't they have PoE by default in a lot of them?
Because if you're running your own stuff with PoE, so if you're using PoE, that means that you're running your own cable. If you're running your own cable, you are already far beyond any problem the ISP is worried about.
Well, and I saw what the ISP was trying to sell, and it was like Wi-Fi extenders that were Wi-Fi based and not backed by cable. And I was like, well, that's just silly.
Okay, so the most common these days, you're seeing a lot of ISPs are starting to bundle Plume. They don't always tell you that's actually the brand of the thing, but Plume is one of the bigger Wi-Fi mesh providers. They are by far the highest performance out of any of them that I've tested over the years. But the majority of their business is not actually selling Plume branded kits retail directly to consumers. They do that, but the only reason they got into that business was to convince ISPs our crap is awesome and you should license it from us. So where you see the Wi-Fi only stuff from the ISPs, these days that's almost always Plume. The reason it's almost always Plume is because they can actually use the magic management bits that tie everything together into like a virtual NOC where you can see everything going on in like all the homes. Plume allows them to bake those libraries into the firmware on their own cable modem. So by doing that, instead of the ISPs just having to disable the Wi-Fi chipset that's already present in a cable modem and have to move like an extra AP to tell the customer to blah, 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 now they can just say, well, everything is Plume. Everything's managed out of this NOC. We may not use that brand. Our customers may not be aware of it. But whether all of your Wi-Fi comes just from the cable modem that the ISP provided, or whether you've also added these additional pods that are just kind of like little Wi-Fi air fresheners. You just plug them into an outlet. They're little tiny knob things. Either way, it's managed the same way and nothing's wasted. So that's usually what you're seeing. And performance-wise, yes, it is absolutely incredibly worth doing. Is it as good as proper wire backhaul access points? No. Is it surprisingly close? Yeah, it is. Way, way, way better than just ISP Wi-Fi out of a single thing and done.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send in your questions for Jim and Alan or your feedback. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.